we've got some cool stuff. We've got another great talk. Erik is around, I think. Erik, you here? Can I page you to the stage? There he is. What's happening,
here.
man?
Hey, how are you?
I'm good. I'm very good. So, Erik, I just got to tell you, since we spoke last, I keep running through my mind. I think you, Erik, you blew my mind when you talked about the symptoms of too much centralization or too much decentralization. I loved that. And I encourage everyone who is here, if you like this conversation or if you like the presentation from Erik, go check out the MLOps community podcast that he was on, where he talks about centralization versus decentralization. That's it, man. Erik, I'm going to let you take over. It's all yours. And you can also vote at the end for if you want a ukulele or meditation.
I don't know what I want.
They both sound so good.
I do like ukuleles, but yeah. So just I'm gonna see if I can just quickly share my screen. Sorry, so it's this like awkward 3 seconds. Do you see it?
Oh yeah, looks good.
Thank you. I kind of didn't name this talk super well. I think I originally called it data engineering isn't software engineering, but then like I realized like what I meant is more like it's not like other types of engineering, and then like B, I call it data engineering, but I really think of like data engineering, data science, machine learning engineering as like sort of adjacent field that share a lot of these traits. Anyway, so that was enough sort of preface about the title. By the way, Demetrios, like feel free to like interrupt me as much as you want to. I don't have like a ton of stuff. I'm Erik Bernhardsson. I spent a lot of time at Spotify where I built the music recommendation system, did a lot of machine learning. I also done a lot of business intelligence, a lot of data engineering, data plumbing. I've also been a CTO for many years. Like I've done a fair amount of front end and back end and led a lot of different teams. Now I'm working on my own thing, which I'll get back to a little bit later. But anyway, so can I see the chat? Oh, okay, big fan of Erik. I wanted to talk a bit about like different sort of types of engineering, and I think my sort of like theory is like there's a lot of like traditional types of software engineering, and like a lot of the sort of tools and best practices in software engineering, like people sort of automatically think like, why data teams need to be more full stack, or data teams need to adopt those tools. And like my theory is like there's a reason why those tools and best practices exist, and there's a reason why some of them might work really well in the data world, but some of them might not at all work well. And so just to sort of kind of take a step back and sort of putting on my CTO hat, sort of a lot of traditional software. This is very crude generalizations, by the way. Like most of my slides, will be very, generalized a lot. But like, I think about like backend engineering, like traditional software engineering, it's like kind of like, you're writing like business logic, and it's kind of like rules. You have like, if order value is more than $100, then shipping is free. You write a unit test for that, you make sure it works, and you kind of deploy it, into a container, and that container runs in the cloud, and there's like, web traffic hits that container, and that container kind of stays there until you replace it with a new container and things like that. In the data world, a lot of these things like do not apply. Like we're not shipping rules to start with. And we're often shipping like very sort of fuzzy things. Like it could be like a machine learning model. It's like hard to know, does it work, does not work. It can also be like insights, you have very sort of weird sort of hardware requirement. You have a lot of like bursty scalability. You might need 100 machines for a little bit, and then like scale it down to 0, and then scale it up again, and then scale it up. So I think it's like kind of useful to think through like, okay, what is the set of assumptions in the sort of traditional software engineering world that led to the like tool chain that exists at, today? And what of those are different? And like, maybe that means like, we shouldn't use the same tools, and, we should have different workflows and different processes. And like I've been coding for 30 years, and, professionally for 10, 15 years. I think it was worth like thinking about like, how much this has changed. Like when I started coding, like, I mean, cloud didn't exist. Containers didn't exist. Like, a lot of sort of how we work with version control and other things like was very different. And I just, there's still like a lot of controversial ideas. So this just goes to say that, like, I think best practices are always like sort of moving target. Like, it always keeps changing, sort of, new tools emerge and then we adopt them, and then, things sort of organically, mutate over time. I think a lot about, okay, like, again, like being a CTO, like, okay, like the goal, I think, to some extent for software engineers, like, we want to build the right tool, like we want to use tools that makes us productive. And what does that mean? What I mean with productivity is almost impossible to measure, but in some way I mean like shipping business value, which is, I don't know, it's very hard to put a number on that. What I've seen though in practice is that productivity can be quite well understood if you think about the sort of the feedback loops. And what do I mean with that? I think kind of walking you through a couple of different examples might sort of help understand what I mean with like fast feedback loops. I was actually doing some front-end development the other day, and I don't know if you've been like doing front-end development, but like to me it's like mind-blowing. Like, you like write some code. I was using Vite, and it's like auto reloading like React component. It just like shows up in the web browser like seconds later. And something like very like visually gratifying, but like, that like feedback loop, right? Like, you're just like hacking on stuff and it like shows up and it's like hack, and then there's a slightly longer loop when you maybe create a pull request and get feedback and things like that. But like generally, I think there's something like very enjoying. It's a lot of fun to do front-end development for that reason, like, because the feedback loops are very tight. Back-end engineering, like, yeah, like, still like, pretty good feedback loops. You write some code, again, if order value is larger than 100 and like, shipping is free. By the way, like, feel free to interrupt. I'm just like talking a lot, so feel free to like ask questions in the Slack or anything. I'm keeping an eye on it. But like generally, like I think the sort of the main tool that's emerged for backend engineers to validate something works is running unit tests. You can run one unit test, you can run many, et cetera, and then you sort of merge it. But like through unit tests, that's like the other way. Like for backend engineers, you get this like kind of fast feedback loop. Now for like analytics engineers, it's a little bit different. Like, you read like SQL queries, and you run them, so just get syntax error, like whatever. But it's also like there's something like kind of like nice about that feedback loop. You sort of write code, SQL, like you get a result, right? And then you look at it and it's like, oh, does it answer your question? Like, no, okay, then I keep iterating. For data engineering, and by like data engineering, again, like sort of bunching together a whole bunch of sort of adjacent field, like data science, like data engineering, machine learning engineering, a bunch of stuff. I feel like something here is broken, right? And granted, like everyone's like feedback loop workflow is a little bit different. And this is sort of, very crude generalization. But I don't know about you, but like every time I like want to do something at like scale, I have to like spend like 3 days like writing YAML and like wrangling with like AWS and Kubernetes and like containerizing things, and my brain just explodes because like all I want to do is like write something and like see if it works or not. And I think that's bad. And I think a lot about that. Like, why is it, is there something missing? And I think part of it is like we're using tools that are sort of optimized for a different domain. And here's like a very terrible scorecard I wrote. I just very subjectively put in numbers here, kind of thinking through these different fields or these different tools. For traditional software engineering, you look at like the top 4 rows, maybe, or and I don't think it's a coincidence that Kubernetes is actually quite popular. Like for the types of challenges that exist in especially like backend engineering, like Kubernetes is quite good. But however, like what if like you remove the top 2, because like they actually don't really matter. Like if you're running data stuff, for some people, the third one doesn't even matter. And like suddenly, like I don't think it's like so surprising that like data warehouses have been, taking a lot of sort of, it's like people don't really think about like data warehouses as versus like Kubernetes. But I actually think, there are some similarities. Like they're both runtimes, like in terms of like running logic. And I don't think it's so surprising, like in this sort of view of the world that database is like doing taking a lot of more, taking over a lot of sort of traditional data workflows. Anyway, this is what I'm working on. So I'm working on this new sort of way where I truly think there's a way to get the best of almost all worlds. Some way to like have that sort of dev prod, like the sort of same type feedback loop, but with the cloud and like with scalability and all those things, and with the ability to write arbitrary code. So stay tuned. I haven't launched anything on it, so I don't even have a website, but it's an interesting field, and definitely feel free to. This is kind of quick. I don't know, Demetrios, I'm happy to spend a little bit of time, talking about this, or any other questions from the group.
Yeah, I get the feeling we'll have some questions coming through. I've got some questions for you. It's not perfectly related to this, but I did read your blog posts about some predictions that you have, and I wanted to talk to you about that while people are scurrying to ask questions. So as a little background, in case anyone does not read Erik's blog post, highly recommended. It's at your website, right, which is on the screen. Now, can you tell us about this blog post and what prompted you to actually write something like that? And there are a few hot takes on there.
Are you talking about the most recent one about the cloud, right?
Yep, exactly. About
Yeah.
AWS, like not going up the stack anymore.
Yeah, I think there's a lot of different like entry points into that blog post, but like one thing I've thought a lot about is like, I think we're actually quite early in cloud adoption. Like we obviously like had, it is modal, by the way, with an A, just to answer the Slack the message. But so go back to your question. I think we're quite early in the adoption of the cloud, and I think one question I always ask myself is like, in this era of the cloud, like, why I was still like provisioning cluster, like thinking about resource management, and like to me, like the inevitability of the cloud is like you have infinite resources. Like computers are very good at like packing things and estimating. Like why can't the cloud just take care of all of that stuff for me? So to me, like the inevitability of the cloud has always been serverless. Now the question is like, okay, why is serverless not more prevalent? And I think a lot of it comes down to like, the first version of serverless tools like Lambda, it's just not good to work with. It's just like kind of does not like fit with like the sort of, and a lot of it I think goes back to sort of what I talked about with feedback loops, right? Like writing a Lambda and like executing it has this like super annoying feedback loop, right? Where you have to like write some code, build a container, upload that container to AWS, then go into AWS and like wait for that container to be like fully whatever it is, like they do something to it. And then you like trigger Lambda, and then like, a minute later, the Lambda crashes and you're like, oh, I have to go into like a tab and look at the logs. And then it's like, oh, the exception is there. And now it's like, and maybe you have to set up some CloudWatch stuff. I don't even know. But then you have to like go back, then you can go back and like, okay, now I'm gonna like write some more code. And this is like this like awful programming experience. So I think for that reason, like I've been thinking a lot about like, what is it that, what is the true sort of end state of serverless? And I think when you look at the, back end and front end development, I think there's been a couple of really interesting companies, particularly like Vercel, who's like, basically saying, or, on the Jamstack side, Netlify, Cloudflare workers to some extent. There's some interesting database companies, like obviously Snowflake and Mongo, so traditional one, but then there's like PlanetScale, Yugabyte, et cetera. And they're sort of taking databases and just making them like serverless. And like, I think to me, like there's a set of vendors that sort of are emerging like at a layer above AWS. You have like AWS, GCP, Azure as like the sort of foundational sort of hardware layer where you can like rent capacity in them. And then there's a set of vendors like at a layer above, that lets you not have to think about all this like resource management and just like lets you use a database. And that's where I think we're going to see a lot of evolution in the next 10 years. And sort of my prediction with the blog post was that I actually think AWS is pretty happy to stay in the lowest level because they're very good at it.
Yeah. So my only thing with that when I read it the first time was I just have a hard time seeing AWS with their infinite resources saying, all right, we're going to lose this one. Let's just put a fork in it. It's done. And we'll stick to what we know best. Like I do understand, especially when it comes to When it comes to AWS, you've got so many different services that they offer and so many acronyms and all that. But at the end of the day, and all of these are really trying to drive this compute and storage, I just feel like for AWS to put up the white flag, or any of them for that matter, GCP or Azure, it seems really out there to me. But I want to hear your take. Like, how do you think that they would just say, see you later?
No, I think, well, first of all, I think there's so many different internal teams in Amazon. It also depends on like who you ask, right? But like, I think it's like interesting to look at Redshift versus Snowflake. Because like AWS like kind of had the opportunity to create Snowflake, but they didn't. And the question is like, why didn't they? Like, why didn't they like take, and they actually like finally sort of released a version of Redshift, which is kind of looks like Snowflake sort of architecturally, just a few months ago. But for a long time, like Amazon had, was the only provider of, a truly scalable cloud native data warehouse, right? But the sort of interesting thing about Snowflake is that Snowflake, let's say a customer is already on AWS, and let's say they're considering, should I use Snowflake? Should I use Redshift? I don't know. And let's say they use Snowflake. Yeah, like AWS, they won't get the money now for Redshift. But as it turns out, like Snowflake, they will want to run it on, in AWS anyway. So AWS will still make money from, the CPU and the storage, right? The storage is S3. And so for AWS, it's actually like the math actually kind of isn't so bad. Like even if they lose business from Redshift to Snowflake, they actually end up getting a lot of that money back. The other thing is like now they completely outsource R&D and sales and marketing to Snowflake. And so I don't know, if you look at the math, like, it's actually like not clear cut. Like, it's not like evident that like necessarily like AWS is worse off, losing business from Redshift to Snowflake.
Yeah, actually, as a friend of mine who worked at AWS said, the house always wins. And so
what does that mean in this context? Who's the house?
The AWS is the house. So they're getting the
I see what you're saying.
kickback, right?
Yeah,
they're getting money from it. So it's great. Totally. And I like this thought that you just mentioned. AWS is outsourcing their R&D to Snowflake and letting those people do the heavy lifting. That's an interesting one that I hadn't thought about. So, all right, I think I can say it now, but wait, I'll wait a sec. But there's a little bit of a surprise because somebody was asking for it in Slack, and I've got a surprise for us in like 2 minutes. But I want to ask some of these questions that are coming through in the chat. One of them being do you think Rackspace is moving up this stack?
I really don't know Rackspace particularly well.
Okay, so no worries. Then we can skip over that one. Oh,
I do think like, in a way, like stable oligopolies are quite good businesses to be in. And like, if I look at like cloud vendors today, I mean, the three big ones are, by far AWS, GCP and Azure, right? And I think there's like a long tail of like smaller vendors, but I think my expectation is like they're always going to be niche.
Yeah, I see that. So here's the surprise for us. Somebody asked in Slack, can we rehash the Mike Erik podcast that happened on the MLOps community? And so I pinged Mike. What were you sleeping, Mike? You were.
No, I'm sitting. I'm honestly just sitting on my couch watching Apply, and so then
I can't believe it. We pulled him back up here. We got him. We've got like 10 minutes to chat. You two get to. I'll moderate a little bit, and I'll throw some questions your way and figure it out. Right now, the most pressing thing on my mind, I think, is. And both of you just gave a talk about certain aspects that you feel in the landscape, the current landscape, how you see things, what you're focusing a lot of brain power on. But are there other parts of the landscape, and Mike, maybe you can go first on this one, that you also are, it takes up quite a bit of brain energy, but you're not actively making anything for it? Like, is there something that you feel like, oh, there's this over here, but
yeah, for sure.
Not right now.
So there's nothing is perfect yet, but you know, uh, I was just thinking about like, you know, the conversation Erik and the three of us essentially had for an MLOps community, which I guess we could go watch again. But you know, I don't even remember exactly the topics we covered here, but just kind of following up on something that Erik was just saying about, you know, adopting the cloud. I see that as still a thing a lot of people are struggling with. It's still really hard. There's, you know, that's a thing for us at Tecton, where we have a lot of people who want to use, you know, they want to use Tecton, and it's, you know, they may not be fully on the cloud, and you know, that's just for a business decision for us. We don't want to, you know, do anything on-prem because we're kind of building for the future, but it's exposed us to the challenges of adopting the cloud, and that has been a thing that it's a very messy process there, and it's not like nobody's trying. There's, you know, if you talk to you know, every major cloud vendor has major investments in helping people adopt the cloud. I mean, Erik, I'm sure you've dealt with every different variant of this. And then even like companies like Snowflake and Databricks, which are not cloud vendors, but they're such major businesses that live only in the cloud, they are also putting in like significant effort into helping on-prem businesses find success in the cloud. And so that's kind of like that's kind of like that symbiotic relationship between those kind of cloud data platforms and the cloud vendors, and then like vice versa. You know, it's to AWS's advantage to just have someone use a cloud data platform, whether it's Redshift or Snowflake. That's great. And so, you know, there's that kind of like duality there, which makes for a nice partnership between them. But I think like that cloud adoption is something that we see really stinging a lot of major organizations still. And I guess like Erik, maybe a question for you. Why is this so hard? Like, what are the biggest elements there that are like still unsolved?
Yeah, and I want to jump in right before, sorry, Erik, hold that thought, because I think I saw a tweet that you sent out, Erik, and it was like something along the lines of, when I was CTO, I never thought about like, oh, I'm going, like everybody talks about this vendor lock-in or like cloud lock-in, but the last thing on my priority list was, oh, I need to go and just lift and shift from AWS to Azure or that kind of thing. That's just something I wanted to pipe in with, but Erik, yeah, feel free to answer Mike's question.
I'll ask your question too, because I have more strong feelings about that one. I feel like that the sort of fear of vendor lock-in, like it's like, let's say you're like building a big office, you know, for your headquarter, like would you be like, oh, you know, I don't want to like lock in a contract with the landlord because like what, you know, it's like, so like, I don't know, like I feel like this, like I'm glad in a way that there's like a small fraction of like crazy people who like build multi-cloud system so that like everyone else like don't have to do that. Because like the fact that there was always going to be like some tiny fraction of people doing it, I think is a terrible idea for them. But the fact that they're doing it means like, you know, cloud vendors' prices are always going to be like roughly in sync, right? Like AWS and it's basically what I said earlier. It's like a stable oligopoly, right? Like there's like three big providers, and you know, this is sort of tacit price collusion, I think, in a way between the three. Like no one's going to start a price war, but on the other hand, like no one's going to like jack up the prices either. So you're going to have this like pretty stable price structure, which means that it also means like it doesn't really matter. Like there's no, like, you know, why would like they like jack up the price for, you know, for you, like, you know, because then they have to jack up the price for everyone, and so I think there's always going to be sort of price parity like roughly between the three, and then for that reason, like it doesn't really make any sense at all to try to build multi-cloud.
So Erik, I've seen that certainly be true for like smaller companies where it's like, obviously there's a huge overhead for building on two clouds, and but I've seen larger companies certainly be able to leverage that threat where they can say, look, we've also built enough on Azure, so we could switch over to Azure. It would be, a 2-year effort for us or something like that. But, if it's going to save us $200 million, we'll definitely do it. And, that's that small number of players, of very large players that have that realistic threat of being multi-cloud or migrating between clouds, that is bringing that pricing parity for everybody, which is super nice.
Yeah, and I think that's
we all
right.
get
It's
the
like,
benefit from it.
there's like some small set of people that do that. By the way, like I think even for a lot of those people, it's not a credible threat. Like, to be honest, because like you just said it, it's like a 2-year effort. Like as a CTO, like it sounds like crazy to me to spend 2 years to move from one cloud vendor to another to save money. Like unless you're like, burning, which like is like true for like very small set of companies, but like for most companies, like the idea of like spending 2 years moving from one cloud to another is insane.
But I think, I mean, just consider that like that could be insane for a technology company, where as a CTO, you're all about building the core capabilities of the business, right? And you're like the company is an engineering company building more technology. And so that kind of translates to, all right, let's stop the business for 2 years. But a lot of companies, they're not technology companies. And like the technology division is just like, running a lot of the back office operations, and it's not a revenue driver. And it's just a matter of like, all right, well, it's a cost, it's a cost center. Okay, let's move to a cheaper area. And I think that's where those threats become more realistic. I don't know of anybody who's actively building, their technology product and trying to build it in ways that will work in multiple clouds. I agree with you on that.
Yeah.
Well, let's kind of like play off of that, because something that I've been thinking about lately is how you have these really well-defined use cases for machine learning, and there are companies like AV, or you have like fraud detection, and you have those use cases that are seeing value in the companies. And then you have other like technology or AI first companies that the business is built around machine learning. And so they're also really interested, or they live and die by machine learning. And then as far as the market goes of other people that are using machine learning, you have this like long tail of other companies that are using machine learning or trying to get into machine learning. How do you all look at that as you're building your new tools? Is it something, I mean, Erik, I don't know if you're specifically building something for machine learning. I don't think you are, but I imagine that when it comes to data and the maturity of data too, like that long tail, there's a huge amount of companies that are doing stuff and maybe not proven out the machine learning use case yet, or just their way of working. And so, yeah, Mike, I'll shoot this over at you first, because I'm sure that you think about this, like that long tail. What does that look like, and how do you think about that?
I'm sorry, I didn't get, there's a long tail of use cases, but what about them?
So basically you've got like, you've got those long tails, but how do you look at them? Like when you're building Tecton, how do you think about like, oh, should I be trying to, because I imagine, and we've talked about this before, I know in prior podcasts where you're talking about how a few people think that they need something and they're not really, they don't understand what they need yet. And they're asking for the faster horse. They're not asking for a car. And so when you have these long tail, like how do you look at building a product around that where it's really vague and unclear?
I think it's for the like building a vendor product. It's the same as if you're like the CTO at a company and you're trying to figure out what does your infrastructure that you're building need to support, and you have a variety of use cases, and some are more important than others, and some are more similar to others and some are more unique, right? And I think in terms of the long tail, there is like long tails that are, that can mean different things, but some is like people with wacky requests that are super unique that are not really justified. So you can think of like the long tail of what are people requesting. And, I've had, when we were at Uber, I just remember one of the VPs saying, hey, we can't use Michelangelo because we need real-time unsupervised reinforcement learning, with like 3 other adjectives there. And I was like, not really sure that that's a thing, but that's one of those really out there requests. But then there's also the long tail of like real use cases. Different use cases actually have real requirements. And so it's important to be able to distinguish between the what people are asking for and the true requirements, and then being able to help those people who are asking for the faster horse map to what their real requirements are. That's something that we spend a lot of time on, and helping understand what are people asking for and what is possible. And then designing and just having like very good internal discipline about, well, we don't want to support things that are not a certain level of reusability unless they provide a certain level of value. So that's just how we think about it at Tecton. But I think it's probably similar for if you're building a platform, internally in a business as well.
I have pretty similar experience. I think, I spent many years in the mortgage industry, and talking to a lot of like traditional mortgage companies, and or talking to people who are like doing due diligence on, in the space, like they would always be like, so tell me about the magic AI machine learning brain that's like doing underwriting on the customers. I'm like, well, first of all, legally, we can't use machine learning to underwrite customers because that's against law in the US. But second of all, like, yeah, we use a bunch of machine learning, but it's like in completely different places than you would expect. And so I think that's, I think that's interesting, right? Like in a way, like, the bet in, investing in like AI technology or like tool chains is a bet that like, it will become more prevalent, and a lot of more companies will adopt it for more places, in more places of the business. But yeah, like my experience is like those places may not at all be where, business people think, the value is like, cause, and like, by the way, 3 years ago, like, people didn't know anything about AI or like whatever. There was like chatbots and like whatever, but yeah, and it's like so interesting how like, I never actually seen like any single chatbot project like actually succeed. And so, but I've seen many other like, search relevance, like, recommendation system, it's so interesting how like, there's use cases that people think they need versus, what actually drives value is like so different. And I think that's, and maybe that's what you touched on, Mike, like there's just so much work on like, sort of also like working with people and like identifying those things.
Brilliant. All right, guys, I got to kick you out. This has been awesome.
Thanks for bringing me back in here. I'll just go back to being on my couch as a viewer.
Yeah, this was cool. This was surprising. Like, I'm glad that this happened. It was very spontaneous. And thank you for the person who recommended we do this. I think it was Prasad. Thank you, Prasad. We got to get you some swag. Reach out to me because that was a great idea and we appreciate it so much. So thank you, Erik. Thank you, Mike. I'll see you all later, and we're going to keep cruising.